Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to continue our industrial series and today we're going to talk about CNC Mill, basically computerized numeric control. So let's dive right into it. Now this is an overview, a rough idea of what the hell is happening. So if you have to understand industry, you have to understand this first because this is the core of industry. Basically it's like heart of basically our industrial nation. Basically it's not a luxury, it's something that you must have. If you want an industrially capable nation, you must have this. Higher the quality of this, the better products you can make. And I don't mean product in terms of like iPhones and all that. Of course those are also made by it. It's just that I'm talking about jet planes, your tanks and all that. So it is very important. Now what does it allow that it makes it so important? Well, during industrial revolution, as in like early 1800s and all that, we realized that it's much more practical and efficient to make what we call mass production. Basically copy one thing 10,000 times. Basically instead of making new car every time, just take one model and duplicate it as many times as you can. So that is what we call mass production. Now in early days we used humans for this, like basically one person who's whose sole job is like, let's say, grinding the wheel, another person whose sole job would be to fitting the nuts in that. Now so most of the industrial operations that you will see in terms of construction phase, basically where you take the raw material and make it into something useful, generally it requires a lot of cutting and grinding. Now CNC machine takes care of that part, cutting and grinding. Now it takes care of it not only in the sense, okay, it can do that, it just also takes care of it in terms of human error. It removes human error. You cannot ask a person to basically cut a circle. It's simply not possible. And if you have intricate patterns into it, let's say turbine head, basically turbine head, I'm sorry, engine has a piston has a head has a very subtle geometry put into it, like exhaust and intake manifold has a subtle geometry into that. If you ask a human to do that, can he do that? Yes. Can he do that like hundreds and thousands of times where you have to mass produce it? No. That's the whole point of CNC. CNC allows you to mass produce things. Basically, let's say you have a fancy wood shop and you're like, oh, hey, I'm selling this pattern. Again, you can ask a person to make this and people do make this. But problem is, like, if you have to make hundreds and thousands of those, again, each of them would be a bit different. Each of them would be perfect. And not to mention, over time, like you can easily see if a carpenter is working, you can easily see it starts to drift. So in those sort of scenarios, it becomes a life-saving. Now in terms of what it can do, basically it's up to you because it's a tailor-made device. Basically you not go and just buy CNC. You're like, okay, what is your need? People will be like, hey, you want a CNC? Okay, what are you gonna cut? You're gonna cut wood, or you're gonna cut steel, or you're gonna deal with cast iron. Each of them have different requirements, so it's tailor-made kind of equipment. And sometimes if you have like very precise requirement, like how SpaceX has for their engines, somebody will design it for you. So that is why it's very integral to our industry. Now, so how does it work? Like in simplest form, there are three main steps. Step number one, user input. Basically you and I are gonna work on it. So how the heck we work on it? Basically we do not send commands like how we control games. We do something what we call CAD and CAM. CAD is basically computer aided design and CAM is basically computer aided modeling. So whatever you have in your mind, basically let's say Raptor engine or something like that, you're gonna design that in the software. Now if you want to learn this software or just for lols, you can do that because there is one very awesome software available for free, Fusion 360 from Autodesk. So you can use your hand there. So this is what we design. Like this is what engineering student will do, this is what engineering firms will do. So once they have this command will be sent to the CNC machine. CNC machine's computer is gonna decode all this gibberish, basically like x, y, y, z, xs, all that, and it will turn it into action, basically where motor and driving, basically how far the motor is supposed to move, how long this motor is supposed to run, like what is the spindle RPM and all that, and then you will have your final action done by generally the milling head. Basically actual mill spindle will grind your part away or cut your part away depending on what you need. Now dentistry also started to use that because earlier days we used to have ceramic teeth. Now most people want to have what we call zirconium teeth. Now zirconium is ludicrously hard. Like it's indestructible, but that's the problem. It is indestructible. How the heck you gonna work on it? Like, can a person grind it to perfect shape? Yeah, it's just if a person has to do like for a whole teeth set, good luck with that. It's gonna cost an arm and a leg. So, and also it's gonna take time. So if like some high celebrity client is there, is like, yeah, you can't tell him like, yeah, we're gonna wait for 6 months so that person can grind it. So generally these sort of things can be done by CNC, and CNC will not give you final finish. You can polish it out afterwards. So that's how it works. Basically you will have three main steps. You design what you want. Basically you tell the computer what you want, computer will decode it, basically whatever you sent it, then there will be action that will get your job done. Now, okay, that's how it works. So, what are the components that make quote unquote CNC mill? Well, I'm not talking about like cheap childish one. That there are people who build a CNC machine for fun. You can do that too. Like if you want to, like people can have a laser cutter to plasma cutter to like high end industrial design. It's up to you. But in core of every high end one, and I'm talking industrial grade one, generally there is a real time computer. Now that real time simply means there will not be any software action that will interrupt it. Basically, it won't be like, hey, Windows update. Yeah, no, that's not happening. So there are sometimes specific operating system built based on Linux generally that allows like complete real time, because you have to understand there is also acceleration and deceleration integrated to basically moving material. If you have a spindle that is moving, let's say from up to down, it has a time variable to it. So you cannot like, okay, the spindle got down, like of course it has a specific time. Everything has a time. Basically it has speed. So where the heck speed is coming from? Speed is coming from time, basically movement across time. So your time must be accurately monitored. So whole system relies on a computer keeping accurate time. So software cannot be like, yeah, just chill man, let's just chill, I'm just updating this background task. No, everything has to be real time. Then you will have power electronics, because okay, software did everything it like it decoded what we classify as G code, and it's sending the command. Now who will send it command to? It will send the command to motor drivers. Now these are the power electronics component. These are the second most power intensive component in your CNC machine. They will consume the quote unquote signal, they will consume the quote unquote power, and then they're gonna turn the motors. This is how your action starts to take place. Like motor, depending on how big your CNC is, how many axes your CNC has, you will have that many motors. Then you will have main axis structure. Now axis structure directly controls like how many axes you have, 3, 5, 10, 12, whatever have you, and build a volume. Now this is very critical. Like if you are, let's say, a home shop who's just like do fancy wood carvings and all that, you're gonna buy a CNC that is this big. Now if you are a shop that sells let's say wooden doors, door is a big thing. You have to have like 3 foot by at least 6 foot or 7 foot, something like that. So you have to have a CNC that can take care of that much. So build volume is directly proportional to axis structure, how big your structures are. So that will be the core component. After that, the final, like the thing that actually does the work, this is all you are doing right now is moving around. So what does the actual quote unquote cutting, drilling and things of that nature? That is spindle system. Now spindle system is the most noisy part in the CNC machine. Basically everything else will sound silent compared to that. So people have now started to use what we call water cooled spindles, so the sound does not become like ear blasting sound. And then the first thing will come to you, like I'm talking about 5 axis. If the universe only has 3 axes, X, Y and Z, how the heck does 5 axes happening? Is it traveling in time and all that? Well, no. 3 axis is what we classify as basic. Now when I'm referring to axis, I'm not referring to object's axis. Basically the object you have, it only has 3 axes. I'm talking about how you manipulate that object. Basically, if let's say somebody give you an object, how 3 axis will simply mean you can do this, 1 axis, you can do this, you can do second axis, and this third axis. That's all you can do. Now when I talk about 5 axis, you can do the same things that you could do, plus you can turn it. This will be the 5 axis part. This is what you can say. Just generally the workpiece are being moved. Now again, depending on the design, like if you are doing an engine block, so you may find it would be easier to move the spindle rather than the object, depending on the weight, size, constraints and all that. So this is the whole point. You will have like generally a basic starting point is 3 axis. You want to do something fancy, 5 axis. If you want to do something custom, let's say mass production, or basically where time is the money and you don't want to like mess around with like 5 axis trying to get your cut, generally you will add another axis if it helps you. So let's say I saw a very old documentary with BMW cars and all that. So they put 1 ton pellet of aluminum and an engine block comes out of that is barely like 200 kilos or something like that. Like the whole engine block was done like that. So it was quite amazing. For those sort of application where you are mass producing and you need precision with time, you have to have multiple axes. So 5 axis in those scenarios is minimum, and you can buy 5 axis right now. Like you go to shop and like, hey, I want 5 axis CNC. They're like, yeah, these are the catalogs, which order whichever you want, depending on the strength, speed and all that. So that's the whole point, multiple axis. So whenever somebody says multiple axis, they are not referring to the object, they are referring to the how you can manipulate it, how many rotation you can add to this. Now, CNC machine is a very old technology at this point in time. It's around, some people say it's as early as 1950. Now, at that time, it was called NC, numeric control, because computer was not quote unquote digital computer back then yet. So you can understand it's quite old. Like even in as early as Apollo era, people were working around with this. So you have a very large variety of this. Like I have seen a YouTuber, like a 14-year-old YouTuber built CNC machine in his home as a summer vacation project. So you can find like from student grade to NASA grade, there are generally used for NASA projects or companies like SpaceX. So the CNC machine comes in a lot of variety. You can build something like this to just understand this, and you can go as high as like a proper machine with independent tool changing algorithm, recovery systems and all that. So there is a lot of range, so your price will be quite dramatic. You will see, let's say Banggood or Amazon, you will have very cheap like $200 $300 CNC machine. Then you will have $20,000 CNC machine. Then you will have $2 million CNC machine. That's cheap part. So there are CNC machines that are so precise, so accurate, that they can make another version of them very easily. So that's the whole point. The more money you spend, like again, unless somebody is scamming you, the higher precision and accuracy you will get. Now that's not important for home shop or hobbyist or things of that nature, but that is very important for an industry. If you are making a jet engine, like if you are making even one component of a jet engine, it must be accurate, it must be reliable, otherwise you will have a plane that will fall out of sky. So in those sort of scenarios, you can understand that. So you can try out with this. You can buy this very funny looking CNC, which is Pocket NC. It has 5 axes for a very cheap price. So you can make, like people have made small RC jet engines out of this, so you can understand this, quite useful. So, and there are some politicians who are like, let's say, loose here, and they thought like 3D printers can make weapons and all that. Here's the deal: this puppy mass produces it, and you can buy this out of Amazon. So I have no idea like what people like smoking or something like that. So that is the whole point of CNC machine. I hope you liked it, learned from it, got at least a rough idea of what the heck CNC is, like why everybody is so excited about it. And if that is the case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.